Hello. This time we're going to explore a greedy coloring algorithm for simple graphs. So, to start with this, suppose that G is a simple graph with n vertices. The first thing that we're going to do is order the vertices from 1 to n, right? Just as indicated here. Then we're going to place a sequence of colors, well, as many as we have vertices, just in case. And once we have that, for each index from 1 to n, we're going to do the following. Assign to the vertex labeled as I the least index colored not applied to the vertices adjacent to that vertex. So we'll start like this. I'll provide an example of two examples of an application of this algorithm. So first, I'm going to label 1, 2, 3, 4, 5, 6. Then I'm going to reproduce the colors that I'm going to label as A, B, C, D, E, F. We may not use them all, but again, this is just for the sake of completing this algorithm. Let's see. Then I'll start like this. So the first one is 1, and I'm going to assign A. Then I go to 2, and I consider this vertex as processed. When I go to 2, I examine what is the least index color not used that is adjacent to 2. Well, in that case, that is B. So I color this as B, and I consider the vertex as processed. Now I move to 3. Well, from 3, I look at the neighbors of 3. Say, okay, what are the colors that I have not used that has the least index? Well, in that case, that would be A. So I'm going to use A here, and I consider this one processed. Now for 4, I may say, okay, 4. 4 is adjacent to 3 and 5. But in this case, we already have used A. So what I can use is use B. So I can use B. Now I moved to 5, right, and process 5. Okay, what are the colors that I have not used on the vertices that are adjacent? Well, in this case, I have used colors A and B. Well, so I may use C. And now we are starting to see why is that we can call this a greedy algorithm. Well, we use whatever is right available. So now we have C. Well, but by the time that I get to 6, right, I examine what is adjacent to 6. Well, to 6, I have 1, 2, and 5. And I have used already colors A, so I cannot use it. I already used color B, so I cannot use it. I already used color C, so I cannot use it. Well, that means that I can use D. So I color this as D, and I consider this one as processed. So what can we say about this? Well, this graph is 4 colorable. Of course, this might not be optimal, as I'm going to show in the next example. Right? Look, I'm going to use the same graph. The only difference is that I'm going to produce a different labeling. So now I'm going to label this as 1 here, 2, 3, 4, 5, and 6. So I complete the first step in the algorithm. Now for the second step, I'm going to use the same colors, A, B, C, D, E, F. And I'll start the process. Say, okay, starting at 1. What is the least index color not used in the neighbors of 1? Well, A. I consider this one process. Now I move to 2. What is the least index colored not used in the neighbors of 2? Well, that would be B. So I color this as B, and I consider this one process. Now I move to 3. What is the least index colored not used in the neighbors of 3? Well, that would be C. So I color this as C. Now I move to 4. What is the least index colored not used in the neighbors of 4? Well, on 4, I have not used A, so I can color this as A. Okay, and I consider this one processed. Now I move to 5. And I say, okay, what are the colors that I have not used and using this index scheme? Well, I have used A and B. So I can use C, right? C. Now I move to 6. On 6, I look, what is the least index color not used in the neighbors of 6, meaning 4 and 5? Well, I have not used B, right? Okay, so I use B, which is the smallest available. So look, what we have shown here is that this graph is 3 colorable. In other words, we can see that the greedy algorithm is not optimal, right? As the coloring depends on the choice of the ordering of the vertices. Well, in this particular graph, we can demonstrate that the 3 colorable is actually optimal. Why? Because we may observe that, for example, here we have a 3 cycle, and a 3 cycle requires 3 colors. So, in particular, at least for this case, this graph is of chromatic number. So, in the first try, we painted with 4 colors, which is not optimal. On this second iteration, we choose a different labeling scheme, and now we managed to color it with 3 colors. But in general, it's not guaranteed that we provide an optimal coloring. Hope that you enjoy it. Take care.